You call setState and expect the component to re-render right away. That assumption has caused me more debugging sessions than I can count. React never applies your state update synchronously. It queues it for later processing. That delay is intentional, and it's the core design that makes React performant. Every setState call gets pushed onto an internal update queue before any re-render happens. React holds all those pending updates until the current execution context completes. Inside a single click handler, 3 setState calls become 1 re-render, not 3. That batching is what keeps your interface from thrashing the browser on every interaction. React's rendering engine runs on a scheduling architecture called Fiber, introduced in version 16. Fiber lets React pause a render in the middle and come back to it later. This is what makes concurrent features like suspense and transitions possible at all. Before Fiber, a large render would lock up your thread and drop visible frames. After React processes the update queue, it starts reconciliation on the component tree. It builds a new virtual tree from all the queued state changes at once. React compares that new tree against the current one to find exactly what changed. Only the components and nodes that actually differ get scheduled for a real update. Once reconciliation finishes, React enters the commit phase to apply real browser updates. This phase is synchronous. React doesn't yield to the browser until it's done. You never see a half-updated component on screen because the entire flush is atomic. After the browser writes finish, React fires layout effects, then paints, then passive effects. Here's the bug that's bitten every React developer at least once in production. You read state right after calling setState, and the value hasn't updated yet. That's because setState is asynchronous. Your closure captured the old state reference. The functional update form, passing a callback instead of a value, solves this. That callback always receives the most current state, regardless of when it runs. Knowing this model changes how you design components that depend on derived state. Never derive state from state in the same render cycle. You'll read stale data. Use the functional updater or consolidate related state values into a single object. The developers who understand this model write components that are predictable under real load.